Happy morning, dear friends. Here's Dr. Ajanta. Welcome to Demystify with Ajay. Dear friends, we are in a machine learning series, and previously we have just discussed mainly in 18th session. We just made how to load the data and mainly related to the data and its structures. And in 19th session, we paid attention only towards the structure and that supports our analytical score, but still didn't pay much attention. And yeah, this exact session, we will focus on the recorded values and we'll take measures to make sure that three main importance regarding the values recorded in the data are addressed. So that three main things, yes. The first thing, we will make sure missing values in the data that have been detected, that we know why this has happened, and that appropriate measure have been taken to address them. And second, yeah, we will ensure that we have taken appropriate measure so that the recorded values are correct. And the third one, yes, we will ascertain that the extreme point in the data that have been detected and appropriate measures have been taken to address them. The first of all main important thing is missing. See, when we just take some records, if there is a missing, yeah, of course, it is something as like an unfilled. No? So yes, missing values, as the name suggests, are values we expect to have, but we don't. So in the simplest terms, missing values are empty cell in a data set that we want to use for analytical goals. For an example here, yes, first of all, let I just include the needed libraries. So here we just go with NumPy, Matplotlib to visualize, and pandas to make the data frames, and towards the Seaborn, that is also for visualization. Yes, dear friends, here we have a table. Okay, yeah, first we are just going to discuss about this missing values and how to detect. Okay, so the first of all, the example here, what we just able to see, kindly just observe this exact table, a simple table. Okay, so the exact table just shows and a data with missing values. Yes, kindly just observe here the first and the third. So if I'm just correct, so here first and the third student, actually it is just a student database. Okay, so this two students GPA, that is a grade point average, is missing. And here the fifth student's height is missing, and of course the sixth student's personality type is missing. Here in Python, of course, dear friends, missing values are not represented or not presented with emptiness. They are presented with as like NaN, so which is in short as like not a number. So while the literal meaning of not a number does not completely capture all the possible situation for which we have missing values. So here NaN is used in Python whenever we have some missing values. And here, yes, dear friends, so let me just make use of this data. See, actually we know missing values on how they presented in our analytical environmental choice, that is mainly with Python. So unfortunately, missing values are not always presented in a standard way. So for an example, having here as like this NaN, okay, on a pandas data frame is a standard way of presenting missing values. However, someone who did not know any better may have used some internal agreements to present missing values with an alternative way, such as missing values MV, or as like none, NONE, or even if it is a numerical 9999 like that, or something norderized as like n/a. So here, if missing values are not presented in a standard way, the first step of dealing with them is to rectify that. So in such a case, yeah, we detect the value that the author of a data set meant as missing and replacing it with numpy functionalities as like np.nan. Even if missing values are presented in a standard way, detecting them might sometimes be as easy as just eyeballing the data set. And when the data set is large, we cannot rely on eyeballing the data to detect and understand that missing values. So yeah, next we just turn our attention to how we can detect missing values, especially for a large data set. And here we are just going to see a large data set. So here it is a thing. So yeah, dear friends, so here we are just going to make use of this data set. So let I just read it, and of course it is a CSV file, and yeah, let me just have here. So this is what our data, yeah, of course it has 8,784 rows is there, okay. Yes, dear friends, here before going on to this, dear friends, every pandas data frame comes with two functions that are very useful in detecting which attributes have missing values and how many there are that. So in such a case, of course, this info, here we just go with it. So here there's info, and one more thing is NA. So these two functions, okay. So these two functions would just able to detect whether the attributes have missing values or not. Okay, let me just see it with an example. So see here, by using this, yeah, let I just execute here. Kindly observe it, dear friends. Of course, this exact air data, actually it is an air quality data set that comprises hourly recording of the year 2020. From 3 locations. Okay, the data sets apart from this NO2. Okay, so this is what that exact 3 locations. So apart from NO2 reading of 3 location, A, B, and C, that has daytime, temperature, humidity, and wind speed, wind direction. Okay, these are all the exact reading we just have. And here, dear friends, of course, we're not just making towards this, the first method, we can use to detect whether any columns of data that have any missing values is what this info method. Kindly just observe, dear friends, as you can see in this thing, yeah, of course, this air_df. So this is what our data frame name. It has 884 entries, that is of data, but here this NO2 location A, it has 8,664, and location B, it is 8,204, and here location C, it is 8,652. Of course, here, yeah, this exact 3 columns, it just says have fewer non-null values, and that means these attributes have missing values. Okay. Now next, the second method, it is all about is NA method. See, actually a method is to figure out which attribute have missing values, which is to use this exact method. And of course, both the pandas data frame and pandas series have this is NAN. That is also, the function can also be used, and it outputs the same data structure with all the cells filled with boolean, indicating whether the cell is null or not. And yeah, let me just see here. Of course, here I'm just going to have the number of missing values. See here, you can just specify it as like an list itself, or here I have just made it to make it as like a for loop to provide you a beautiful structure of output. So with the heading as like number of missing values, and all these values, that is all these columns, I'm just going to check with an ECNA. So of course, directly you can just make use of this, but here to know it, or to maybe it is in a readable manner, I'm just making here, and kindly observe here, dear friends, when on just executing this, yeah, you are able to see that is this NO2 reading in all these three location has a missing values. Okay, so that is what here we are able to see, and this only confirms that is deduction of missing values we performed previously, the same thing. Okay, so the same thing using this info function. And now that we know how to detect missing values, so let turns our attention to understand what could have caused this. What could have caused this? So these missing values are has been presented, and dear friends, actually this dealing of missing values, see, usually when we just make use of dealing with the missing values, we first and foremost need to know why this happened. It is very much important, and here I just want to say, of course, when you just go towards this causes of this missing, of course, mainly it is all about human errors. And this sometimes if you just go with something as like a survey questions, yeah, some respondents may refuse to answer a survey questions, or the person taking the survey does not understand the questions, or the provided value is an obvious error. Okay, so it would be deleted, and not enough time to respond to questions, and lost records due to lack of effective database management system. That is also one among the thing, and intentionally deletion and skipping of data collection, and a participant exiting this middle of study. If you are just having any survey or any other thing, that's some middle of the thing itself, if they want to quit or they want to skip, yeah, they can just make it no. So in that manner, and third party tampering with blocking of data collection, that also comes here, and something as like missed observation or sensor malfunction or programming bugs. So when working with the data as a data analyst, sometimes all you have in the data, and you do not have anyone to whom you can ask questions about the data. So the important thing here would be to be in questions about the data and imagine what could be the reasons behind the missing values. So committing the preceding list to memory and understand these reasons will be beneficial to you when you have to guess what could have caused these missing values. It goes without saying that if you have access to someone who knows about the data, the best course of action on finding out the cause of missing values is that also ask the informant. So regardless of what caused missing values from a data analyst perspective, so we can categorize all the missing values into three types. Understanding these types will very important in designing how missing values should be addressed. Okay, I just let you have it. So what are all the three types? So first of all, one missing. So here before going on towards it, I just specify you, dear friends, one missing value or a group of missing value in one attribute could fall under one of the following, these three types. So first of all, it is missing completely at random. Missing completely at random. Second one, missing at random. And the third one, it is missing not a random. So there is an ordinal relationship between these types of missing values. Moving from this, missing completely at random, or to moving not a random, missing at a not a random. So the missing values become more problematic and harder to deal with. From this MCAR is used when we do not have any reason to believe the values are missing due to any systematic reason. When a missing value is classed as MCAR, that is completely at random. The data object that has a missing value could be any of the data object. For instance, if an air quality sensor fails to communicate with its server or to save record due to some random function or fluctuation in the internet connection. So the missing values are of this completely at random. So this, because internet connection issues could not have happened for any of the data objects, but it just happened to occur for this. On the other hand, when we just go for missing at random, see, when some data objects in the data are mostly likely to have missing values. For instance, if a high wind speed sometimes causes a sensor to malfunctions and render it unable to give a reading, the missing values that have happened in the high wind are caused with missing at random. So the key to understand this missing at random is that the systematic reason that leads to having missing value does not always cause missing values, but increases the tendency of data object to have missing values. And lastly, missing not at random. See, this happens when we know exactly which data object will have missing values. For instance, if a power plant that tends to emit too much air pollutant tampers with a sensor to avoid paying a penalty to the government, the data objects that are not collected due to this situation would also be caused with MNAR, that is not at random. And here there is missing not at random values, that is missing values are the most problematic ones, and figuring out why they happen and stopping them from happening is often the priority of a data analytics project. Okay, now let me just learn how we can use this data analytics tool to diagnose the type of missing values. And yes, dear friend, here I just want to let you have with this three diagnosing functionality itself. Okay, I just show you one such a case. Okay, so here coming towards dealing with this. So I just take towards diagnosing itself. So dear friends, when I'm coming towards this diagnosing functionality, an attribute with missing values has in fact the information of two variables, that is itself and a hidden attribute. Okay, so itself and a hidden. And the hidden attributes is a binary attribute whose value is 1 when there is a missing value or a 0 otherwise. So to figure out the type of missing values, that is these type of missing values, all we need to do is to investigate whether there is a relationship between this hidden binary variable of the attribute with the missing values and other attributes in the data set. And here, dear friends, when on just making towards this type, if it is an MCAR completed, okay, so we don't expect the hidden binary variable to have a meaningful relationship with other attributes. And here when we just specify at missing at random, yeah, we expect a meaningful relationship between the hidden binary level, that is the variable, and at least one of these attributes. And when we just go for not at random, yeah, we expect a strong relationship between the hidden binary variable and at least one of the other attributes. Okay, so now let me just have this. Okay, we will continue using this RDF, that is this exact data frame. Okay, and with this exact data frame, we are just going to diagnose the missing values. Okay, and yes, dear friends, to diagnose the types of missing values, there are two methods. It is one is visually and towards statistical method. Okay, so this diagnosing method must be run for all the attributes in the data sets. Okay, so here of course we have 4 numerical attributes are here in the data set. That is of course here as like temperature, humidity, wind, and wind direction. Okay, so these are all the numerical, and there is one thing as like date and time. Of course, it is the data that can be unpacked into 4 categories. Okay, unpacked in 4 categories as like a month, day, hour, and weekday. Of course, this we have already discussed in pandas, I think so. So, how to make use of date and times using pandas. And yes, dear friends, so the way we need to run the analysis is different from numerical attributes than for categorical attributes. So first we will discuss about this numerical attributes, and then we just turn our attention towards categorical attributes. Okay, so first of all, let me just start with this temperature. It is a numerical attribute, and also we first do the diagnosis visually, then we will do the statistical. Okay, so here we just go with this. Yes, and yeah, the visual diagnosis is done by comparing the temperature. Okay, so temperature value for the 2 population, that is first the data object with missing values, that is on that is NO2 location A, and the second object with no missing values for NO2 location A. Okay, so we can either use a box plot or histogram to do this. Let us use both. Okay, so first of all, let me just go with the box plot and then we have histogram. And yes, dear friends, so here this exact code snippet shows the box plot that compares the 2 population, and here I just execute here. Okay, so which it just shows, yeah, this is what without missing values and with missing values. Looking at the box plot in this screen, of course we can see that the value of temperature does not meaningfully change between the 2 population. See that that shows that the change in temperature could not have caused or influenced the occurrence of missing values. So both the things, when you just observe here, both are of course almost equal. Okay, fine. So let me just, we could also have done this analysis using this histogram. So yes, by using this, yeah, let me just have a histogram. And yeah, this exact snippet confirms the same conclusion, I think so. Of course. So kindly just see here. Okay, so this exact histograms also confirms the same conclusion we arrived at when using this box plot. Yes, as we do not see a significant difference between the 2 population. Okay, so we conclude that the value of temperature could not have influenced or caused the occurrence of missing values. So lastly, we would also take towards a statistical method. See, actually towards this statistical method, I just want to specify one particular thing. Dear friend, here when we just go towards this statistical, I just want to specify with 2 sample t-test. Okay, I just already specified it in the statistic thing. See, this 2 sample t-test evaluates whether the value of numerical attribute is significantly different among the 2 groups. Okay, here if we just have 2 groups, this is what. So here the 2 groups here are the data object that have missing value and without missing value. Yes, that is what we have seen here previously before this. Okay, so by using this box plot, and even though the histogram we have just done with both the things, but anyhow, let me just have the same thing okay, here in this two sample t-test. And in short, this two sample t-test hypothesis that there is no significant difference between the attributes value among the true groups, and then calculate the probability of the data that is turning out the way it has if the hypothesis is correct. Okay, so this probability we just call it as like a p-value. Okay, so if the p-value is very small, we have meaningful evidence to suspect the hypothesis of the two sample t-test could have been wrong. Okay, yes, we can easily do any hypothesis testing using Python. Okay, and here we just go with the exact. So we have included the library for statistical output. Okay, and this exact function which it just makes use of two sample, that is t-test. Okay, and yeah, let me just execute it and kindly observe, dear friends, by using this t-test index, that is, okay, this exact function, it just gives, all we need it is to pass the two groups of numbers. So yes, we have given, that is, one with the exact missing values and without the missing values, and yes, the value which we just received, it is exactly the statistics value, and kindly just observe the p-value, it is 0.95. And dear friends, when on specifying this exact p-value of a t-test, it is very large out of 1, that is 0.95. It is very large out of 1, which means we do not have any reason to suspect the value of temperature that can be meaningfully different between the two groups. So this conclusion confirms that one, that we arrived at using box plot and the histogram. And yeah, here we showcase that code for diagnosing the missing data based on only one numerical attribute. Okay, only one numerical attribute. So the code and analysis for the rest of the numerical attributes are similar. So when we just do it towards one numerical attribute, yeah, let me just see it completely, and let me just make a small diagnosing also. See, to do a complete diagnosing of missing values based on this numerical attribute, of course, dear friends, a similar analysis to what we did for this temperature attributes need to be done for all the attributes. Okay, so while each part of the analysis is simple to understand and interpret, the fact that diagnosis, analysis have many parts that makes very organized way of coding and analysis. So to do this in an organized way, we will first create a function that that performs all of the three analyses that we done for the temperature. Okay, apart from the data set, the function takes the name of the numerical attribute we want to perform the analysis and the Boolean mask that is true for the data object with missing values and false for the object without the missing values. Okay, so the function here, yes, what it just going to output is, yes, of course, it is just going to give us the box plot. Once again, I just scroll a little bit above, so kindly just see here. We are just going to have the histogram, and of course we are just going to have the box plot for all the three. Okay, all the three, well, so not only three, all the attributes whichever we have just given, and of course we are also going to have the values, that is the p-test value, that is p-value, and t-test for the imputed attributes. And let I just execute this, and kindly just have, let me just have 1 second, dear friends. So this is what the exact function. Okay, and yes, we are just going to have this, and let me have each and everything. Okay, so for temperature, for humidity, for wind speed and wind direction, all the attributes, we are just going to call the same function here, and we want to know the exact visualization. And kindly observe, dear friends, I just scroll slowly. So this is for the temperature. So kindly just observe, this is for the temperature. And next it is all about the humidity. Kindly observe. Yeah, here we have an outlier. Of course, we are just going to discuss the outlier in the next session. And kindly see the exact distribution in the histogram happened in the humidity. And here we just get the p-value and t-test value of the humidity. And next it is all about the wind speed. Okay, so many datas are about to be outliers. And yes, without missing values and with missing values, kindly just observe the data distribution and towards the p-value and the t-test value. And last but not least, it is all about the wind direction. Kindly just observe both the things. So surely you can just see the difference between the with missing values and without missing values. And here too. Okay, so this is what the last p-value and t-test value of the last variable, that is wind. Okay, and dear friends, here after execution of this code, okay, which just create that is a diagonizing MV numerical, that is what the exact function we have called. Kindly just see, this is what the exact function we created and we executed. Okay, so with this code, yeah, it just executed, and here we made it as everything useful on location A. Okay, and this happened due to any systematic investigation whether this missing values of this location A happen due to any systematic reasons that are linked to numerical attribute in dataset or not. And of course, here we just observe, this is the exact code we just done. And running this exact code, yeah, each report has a 3-part. That is what I have just scrolled slowly. So yes, diagonizing report, one for each code as on numerical attributes. And yes, dear friends, so studying the and ensuing report from the code, yeah, it just shows that the tendency of missing value under this location A does not change based on values of either numerical attribute in the data. Okay, now let me just go on to the same similar coding and analysis for categorical attribute, and likewise what we did for the numerical attributes. And let's do a diagonizing of one attribute first, and then we will create the code that can output all the attributes which we all need. So as like this, which we have just done it for numerical. And yeah, one attribute that we will do diagonizing, it is for this weekday. Of course, you may know that is this exact weekday, yeah, does not have a categorical attribute. Of course, this RDF, this data frame doesn't have a particular column, but you would be right. Yes, we have unpacked it by the date. From the date time attribute, yeah, this can be given. Of course, we have already discussed. We just got this 4 attributes, that is month, day, hour, and week. And once on executing, of course, kindly observe what we have just got is a new 4 attributes. So this is what. So here month, day, hour, and weekend. And of course, in behalf of 8, here we got 12 columns. Okay. So this is what. And yes, dear friends, on making this particular execution, yes, after running this proceeding, yeah, we are able to now see totally of 12 columns is that. And now, yeah, let me just make a performance on towards this one again. I just want to know with it. Okay, so yeah, we can perform a diagonizing of missing values mainly on towards the same location A. okay, based on the weekday. Weekday, that is the categorical attributes. And yes, of course, here we are going to make use of a plot, okay, and I just execute it. Kindly observe, it is a bar plot, and have a comparison of this. It is all about the weekdays, okay, and this data visualization just compare this total, both the application based on the categorical attribute, that is weekdays. Okay, and looking onto this, we can see that the missing value could have happened randomly, and we don't have a meaning trend to believe there is a systematic reason for missing value happening due to the change. Kindly observe, due to the change, of course, the value of RDF, that is R_DF, the data frame, and mainly on towards weekday. And yeah, let me just have a similar statistical diagnosing also by using here we are just going to make use of chi-square test of independence, that is the statistical test. And here, dear friends, of course, in short, for the situation, this exact test hypothesized that there is no relationship between the occurrence of missing value and the weekday attributes. Okay, so based on this hypothesis, the test calculates p-value. Okay, the test calculates the p-value, that is probability of data we have or happening if the hypothesis is true. So using the p-value, we can decide whether we have any evidence to suspect a systematic reason for missing value. And yes, let I execute it. Okay, so this exact code, it just shows the chi-square test of independence being performed using this chi2 contingency. This is the exact function from scipy.stats. And yes, of course, this code uses the crosstab to create a contingency table, that is visualization tool, to investigate the relationship between two categorical attribute. Okay, and yes, then we are just going to make use of this contingency, and kindly just observe, dear friends, we are going to have the contingency. Okay, so to know the contingency of this, and here we are just going to call the contingency function to perform the test, and the output some values. Okay, so it just shows the outputs, but not all of them are useful for us here. Okay, so by using this, it just shows the chi-square test of independence to evaluate whether the value of this weekday is different between the data objects, that is location A, missing value, and without missing value. And here, kindly just observe, dear friends, one particular thing which I just want to specify here is the exact p-value. Okay, so the p-value is 0.417. Okay, so that confirms that observation which we made previously, that is, yeah, which is that there is no relationship between the occurrence of missing value in location A and the value of weekday. And the fact that the missing value happened the way they did could have just been a random chance. So here we showcase the code for diagnosing missing values based on only one categorical attribute. So the code and analysis for the rest of the categorical attribute are similar. So now that you know how to do this for one numerical attribute, and we will next go for we have done here with one categorical attribute, and now next we create a code that outputs all we just need for missing values using categorical attributes. Okay, and yes, dear friends, so here we are just going to have it. So this is what, for this we are going for categorical, and of course to do a complete diagnosing of missing value, a similar analysis to what we did for the weekday attribute needs to be done for all of the other categorical attribute. So to do this an organized way, yes, we created a function that performs the two analysis which showcased to be done for with missing values and without missing values, and along with the data set. Okay, the function takes the name of the categorical attribute we want to perform the analysis and the Boolean mask, which is true for the data object with the missing value and false for the data object without missing values. Okay, so the function outputs here, we are just going to have the same thing as with a plot. Okay, and as I have already specified previously, so here it is also a bar plot. Okay, and the p-value and the chi-squared test. Okay, so chi-squared test of independence for the inputted attribute. So let me just have it for all the attributes, and kindly have an observation, dear friends. So this is the missing value for month without missing and with missing, and it is all about the attribute month. And here we have the p-value of chi-squared test, and next I slowly scroll down, and this is for the day. Kindly just observe the difference between the with and without, and here we just get the chi-square test. And next it is all about the code that is for hour, and this is without missing and with missing values. And we have the chi-square, and obviously we already discussed about the weekdays, and anyhow here it is just given. So after running this code, we just discussed about that location A, and when you execute this code, we have just given 4 diagnosing report. Yes, for each the diagnosing using a bar chart, and next for each 4 attributes we just got the diagnosing using a chi-squared test of independence. And I am studying on towards this report that shows that the tendency of missing value under this location A does not change based on values of either categorical attribute in the data. So combined with what we learned for numerical attributes earlier, actually it is a sub part. Okay, so what we just learned about categorical attributes, so we do see that the none of the attributes in the data, namely as like temperature, humidity, wind speed, or wind direction, weekday, day, month and hour, so may have influenced the tendency of missing values. So based on all the diagnoses that we ran for those missing values, we conclude that missing value mainly on this location A are of a MCAR type. That is, of course, we have already specified, that is when on just specifying the exact type of missing type, it is missing completely at random. Okay, now let me just as we have already determined, okay, let also diagnose whether we are going to have the same missing values in location B and location C. Okay, so here we just go with it, and lightly I scroll here, and here we just have it, dear friends. So yes, to diagnose the missing values in location B, we are going to need the same, exactly the same analysis what we have done in the location A. Okay, so of course the coding part we are just going to call it twice the thing. One is for numerical attribute and for the categorical attribute. We have already made use of this diagnosing MV for numerical and diagnose MV for categorical function that we already created to run all needed diagnosing in order to figure out which type of missing values happen under this location B. Okay, so let I just execute it. Okay, so this produced exactly a long report that investigation whether the tendency of, I just scroll slowly, okay, tendency of missing values, whether it is happening, may have been influenced by the value of any categorical or numerical attribute. Kindly just have, this is the humidity, and it is all about the wind speed, and it is wind direction. Of course, we are able to see this, and the histogram, and towards the month, the day, hour, and the weekday, and we are able to see the chi-square. Okay, so of course, after viewing this report, yeah, you can see that there are a couple of attributes that seems to have a meaningful relationship with the occurrence of missing values. Okay, so these attributes are, of course, I just let you know which are all the things. First of all, I just scroll above slowly. So here, of course, we are able to see a small difference in this temperature, and here, of course, wind speed. Yes, of course, wind direction. Okay, of course, month, and not here. Okay, so yes, of course. So the attributes are temperature, wind speed, wind direction, and month, and of course we are able to see it mainly. Okay, and let me just have the same thing. So making on towards this. Yes, in short, of course, we are able to see that is the higher the wind speed, value tends to increase the chance of having missing value. That is what we are able to conclude. Okay, now I let execute the location C. Okay, so towards this location C, we only need one just line, that is the same thing. Here we are going to make use it as of location C, just a simple changes what we have just done it previously. Okay, once the change is done, applied, yeah, we are executing the same code, and yes, on executing it, I just scroll slowly. Kindly observe it. Here it is the temperature with the missing, and we have got a t-test value, and we just have the next one. It is all about the humidity. Okay, humidity, this one. And we have the wind speed. Of course, observe the difference, dear friends. And wind direction. Okay, so this is without and with missing. And next we are just going for the categorical as like month. We have the chi-square test. Okay, 0.999, and for the day it is 4.56. Okay, and for the hour, the chi-square test value, it is 3.38. And oh, kindly just observe the weekday. The changes. It is 1.554. Yes. After execution of this, yes, it is just known that it turned out that is group of here, when we just have the location C, has been taken advantages of the resource of that particular plant. And yes, in this last piece of this information, the diagnosis brings us to the conclusion that the missing value in location C is the type of NAR, that is missing not at random. So such values are missed due to a direction reason as to why the data has been collected in the first place. And dear friends, a lot of times when a data set has a significant number of MNAR missing values, the data set becomes worthless and cannot be of value in meaningful analytics. So a very first step in dealing with this MNAR missing values is to prevent them from happening ever again. Okay, after discussing how to detect and diagnosing. Okay, so let me just go towards how to deal with these missing values, and kindly just have a note, dear friends. Here we have a very good way of how to deal. Okay, so there are 4 different approaches to deal with this missing values. As like the first approach, it is to keep the missing values as is. Dear friends, keeping the missing value as is, it is actually this approach, keep the missing value as a missing value and enter the next stage of data processing. So this approach is the best way to deal with missing values, mainly in 2 situations. The first situation is you would use this strategy in case where you would be sharing a data with others and you are not necessarily the one who is going to be using it for analytics, or in this way you will allow them to decide how they should deal with missing values, okay, based on their analytic needs. And second, if both analytical goals and data analytical tools you will be using can seamlessly handle missing values. Okay, so every time if you just have for an example the data object with missing values and the other data object is being calculated, a value will be assumed for those missing values. So the assumed value will be selected in such a way that the assumed values will not help. So the data object with the missing value will be selected. So in other words, a data object with missing values will be selected as one of the nearest neighbor only if it is non-missing values. So this happens as like yeah, we would just discuss this in KNN algorithm. Okay, so it just adjusts in this way. So then it would be best if we keep the missing values as is. So as to meet both of the listed goals in dealing with missing values, that is as like keeping as much information as possible and avoid the introduction of bias in the analysis. Okay, so yes, this is as like the first approach which usually happens. And second approach, it is all about remove data objects with missing values. See dear friends, actually this approach must be selected with great care because it can work against the 2 goals of successful dealing with missing values, that is not introducing bias in the data set and not removing valuable information from the data. So for instance, when the missing values in the data type are of MNAR or MAR, that is not at random or at random, we should refrain from removing data object with missing values. So that is because doing so means that you are removing a meaningfully distinct part of the population in the data set. Even if the missing value are of type of this completely at random, we should first try to find other ways of dealing with missing values before turning towards removing the data object. So removing data objects from a data set should be considered as a last resort when there are no other ways to deal with missing values. And going for the third approach, remove the attributes. Remove the attributes with missing values. That is, remove the attributes in the sense the column. So when most of the missing values in the data set come from 1 or 2 attributes, we might consider removing that attributes as a way of dealing with the missing values. Of course, if the attribute is a key attribute without which you can't proceed with the project, facing too many missing values in the key attribute means the project is not doable. Okay. So however, if the attributes are not absolutely essentially to the project, removing the attribute with too many missing values, might be right approach. Okay. And yes, the last but not least, estimate and impute the missing values. So in this approach, kindly just see here, the term imputing, it is, see, actually captures the essence of what this does to a data set. We put value instead of missing values, while knowing that this could cause bias in our analysis. And if the missing values are of missing completely at random or missing at random in the type, okay, the analytic we have chosen cannot process the data set with missing values. So imputing the missing values might be a best approach for this type of thing. And of course, dear friends, see, actually more common misconceptions about the process of this estimation and imputation is that we want to impute missing values with the most accurate replacement. That is not correct at all. Okay, so when imputing, we do not aim to best predict the value of missing value, but to impute with values that would create the least amount of bias for an for our analysis. Okay, for our analysis. And of course, kindly, dear friends, when we just want to make this type of, kindly understand the different approach to deal with these missing values. Okay, so let's put things together step by step, and let me just have a small analyticals running here. Okay, I just want to show you a detailed example of each and everything. So yeah, let me just have the same R data frame. Okay, R data frame whose missing values we detected and diagnosed earlier. Okay, so I just execute it here, and of course we have 12 columns, I think so. Yes, we have 12 columns. Okay, so yes, the exact missing values which we just had it in the A, that is location A. Kindly see here, this is what location A. Okay, what we are just specifying is, yeah, since the missing value are not of missing NAR, that is not at random type, and a bar chart can easily handle missing value. Okay, so the strategy we choose to deal with missing value is keep them as it. Okay, keep them as it. So that is what we are doing here. And yes, on viewing this, of course, here we are observing about two things. Kindly just observe here, that is mainly by using the group by and the mean function. Okay, so this we are able to handle missing values, which is very easily able to do. And when the data is aggregated and the number of missing values is not significant, yeah, the aggregation of data handles the missing value without imputation. So in fact, this mean function ignores the existence of attributes with missing value and calculates the mean based on data object that has a value. Okay, now let me just go with an example to the same R data frame. And yeah, first we have done already. And yes, dear friends, we know already that this location A, it is of a complete at a random type. However, some assume something like we are just going to plot it with an line plot. Okay, and let me just execute it, and I just let you know. So see here, so these are all the exact missing values. Kindly just observe. This line plot can handle missing values easily. It is. And previously itself I just specified we are just going with the strategy as like keep as it is strategy. Okay, and yes, dear friends, we just see this line plot or cut in between due to the existence of missing values. Kindly just see, observe this, each and every one having the missing values. Okay, so yes, dear friends, yeah, that we are here done and there is no need to do anything further. However, if we would like to deal with these missing values and remove the empty spots in the line plot, yeah, we would need to use something as like interpolation as the missing values are of MCAR type, and the data is as like time series data. Okay, and yes, dear friends, let me just go with a code snippet here with an interpolation, and we are just dealing with an linear. Okay, and this function, this interpolation function, is to impute the missing values with the method of linear, which is used. Okay, and first of all, I just execute here. So see here, whichever the exact cut lines, now it has been filled. It will appear as through that empty spots are connected with the ruler. Yes. Okay. So what it is the exact function imputes with the average of the data points before and after. That is what the main function of this interpolation. And kindly just observe the above image and to the image below. So kindly just see, this is what with the missing data, and kindly observe the same plot, line plot after interpolation with the average value. Kindly observe. It is what's now connected. It is what's now connected. Here we just got connected. Okay. Yes. Now let me just move on to the example 3. Dear friends, this example, of course, the same thing which we have taken, that is location A and location B also. So location A here completely at random type, and that the same thing happened in location B is MAR, that is at random, missing at random type. So as neither of the attribute has this missing not at random, okay, so the bar chart can handle the missing values, and of course we are going to keep as it is. That the strategy, that is the approach 1 we are just going to have. So nothing much here. So of course the same which we have just done in the example 1, that is what the same thing. So it is group by and with the mean. Let I just observe here to have that. Okay, that's we got. And last but not least, so dear friends, here we are just going to have location A, location B and location C. Okay, and kindly just observe, it is all of all the 3 types of data, MCAR, MAR and MNAR respectively. Okay, and as we have already mentioned, dealing with this MCAR and MAR, that is from location A and B, and for this we already saw we are just using keep as it is strategy. But for M and AR, yes, we need a question. We need an answer for the question. That is, are the M and AR missing value essential attributes or not? If it is an essential attributes, what we have to do? Of course, we have to make an imputation. Kindly just understand the exact concept. If it it is an essential attributes, keep deep understanding about the analytics data goals and 2 different analytical situations. That is, we may have to deal with the missing value differently. The one such which I just specified, yeah, this MNAR in this location C. Yeah, you can, instead of sending them that we have requested, we need to reject their request and instead inform the regulatory body that is, yeah, this is the existence of missing values. So this is because a bar chart would be misleading as the missing values are due to data tampering. So we intentionally remove that. And another situation, of course, which a researcher would like to investigate as like general air pollution in different region. So here, of course, therefore also we here when we just go for MNAR type, the systematic reason behind them is non-essential to our analytical goals. So therefore we also go with the same which we have already previously done with the keep as it is. So of course, dear friend, so here keep as it is strategy only, although used here as like group by and with the mean, and here we just go with this. Yes, here we just go with this plot. And of course, dear friends, yeah, we have discussed a lot related towards this, how to deal with the data. And now I think so you are capable of detecting the missing data and how to diagnose the missing data and how to deal with the missing values, mainly for both the technical and analytical standpoint, and mainly for numerical and categorical data. And I think so this video would be informative for you. Kindly make a like and subscribe if you are not yet done, and so that you would just receive every videos in time of with a notification. So I think you would get a knowledgeable information from this video, and see you in the next video, dear friends, and happy learning.